Hello and welcome to Chapter 9, Section 8. Today we are going to work on completing the square. It's relatively easy to factor quadrilaterals if they are perfect square trinomials. In fact, often you can just look at them and see the answer. If your equation isn't a perfect square, you can make it that way. And this way it makes factoring your quadrilateral a little easier. And that's called completing the square. So let's start with x squared plus 6x plus 9. Now remember that when we were checking to see if the trinomials were perfect squares, what we did was we took the square root of this, of c, and we multiplied it by 2 to get to b. So 6 is really 3 times 2. Now, when we do this, we're going to go backwards. We're going to know what b is, and we have to find c. c is half of b squared. So our perfect square factor is x plus 3. So when we do FOIL, it's x squared plus 3x plus 3x plus 9. And 3x and 3x is 6x. So we're taking half of 6, which is 3, half of 6, which is 3, and we're squaring it to get to 9. So if we're given this and this, we can come up with 9 in order to finish it, to complete the square. Let's try a couple of these together. Right now we have x squared plus 10x. What do we need to complete the square? Well, we want to find half of 10, which is 5, squared, which is 25. Half of negative 9 is negative 4.5 squared. However, in this chapter, it's not interested so much in exact numbers as it is holding on to those fractions. So yes, you can put this in your calculator, but the fractions we're going to be able to manipulate a lot easier. So instead of writing it like this, we're going to write it like this. And when we square it, it's going to be 81 over 4. And it's obvious that this is a perfect square, where if we squared this, it wouldn't be obvious. But because we understand what square roots are, we can see this and know that it's a square. All right? Give this a shot for check it out number 1. Pause here for a minute and come back when you're done. So with check it out number 1, we did half of 12 is 6 squared is 36. Half of negative 5 squared is 25 over 4. And half of 8 squared is 16. Okay? So how do we use this to our advantage? How do we use this if we already have a C and we want to use this easy thing about completing the squares to make this work for us? What if we had a problem like x squared plus 4x minus 21 equals 0? This is random. You don't look at this and say completing the squares, but we know that completing the squares is easy. So first we're going to get rid of that. X squared plus 4x equals 21. Then we're going to look at completing the square. I'm going to look at this. I'm going to say 4 over 2 squared, and that equals 4. So I'm going to stick this 4 in here. I'm going to say plus 4. But if this is plus 4, this also has to be plus 4. So now when I look at this, I know that this is x plus 2 squared, because these are easy to see. But x plus 2 squared doesn't equal 0, it equals 25. So when I take the square root of both sides, x plus 2 equals plus or minus 5. So x plus 2 equals 5, or x plus 2 equals negative 5. So x equals 3, or x equals negative 8. So it's easy to find our zeros. So when we're finding our perfect square, let's figure out our steps. The first step is to make sure that you're rewriting it into this format, ax squared plus bx. And you want to make sure it's equals c because we're going to stick another number in here. Then we're going to complete the square by adding b over 2 squared to both sides. This now is going to be our new c. We're going to stick it in here, we're going to stick it out there. We're going to add it to both sides. Then we're going to factor this part of it, the perfect square trinomial. And you're going to take the square root of both sides, and you're going to solve for both the positive and the negative. So let's try this with our steps. First, we're going to write it in this format. Then we're going to complete the square by adding 14 over 2 squared. 7 squared is 49. So we've got x squared plus 14x plus 49 equals 15 plus 49. We're going to factor our perfect square trinomial. This is x plus 7 squared. 49, 59, 64. And then we're going to take the square root of both sides. So x plus 7 equals plus or minus the square root of 64. And we're going to solve for both the positive and the negative. X equals negative 7 plus 8, which is 1, or x equals negative 7 minus 8, which is negative 15. Try check it out number 2. Pause here and come back when you're done. Check it out number 2. I copied the problem wrong, so it didn't end up working out until I fixed it. That's a negative 9. So I've got the 9 on that side. Half of 10 squared is 25. And 25 plus 9 is 16. So x plus 5 squared is 16. And so I'm going to have x equals negative 5 plus or minus 4, which is going to give us negative 1 or negative 9. Here I'm going to add 5 to both sides, complete my square using 16. 16 and 5 is 21. T minus 4 equals plus or minus 21. Now, if our perfect square is not a perfect square, leave it as this. This is a reasonable answer. You don't have to figure out what the square root of 21 is and do all of that. Sometimes your book does it this way, sometimes it doesn't. This section it seems to not, so let's leave it as that. Okay, next up. What happens when we add a? Ax squared plus bx plus c equals 0, and we want to complete the square. The easiest thing to do is to divide by a. Everything. Divide everything by a. Negative 2, negative 2, negative 2, negative 2. So we've got negative 2 times x squared minus 6x plus 10 equals 0. Now we know that negative 2 doesn't equal 0, so this drops off because that's not one of our zeros, so it's not one of our solutions. Now we want to look at this number, and we want to complete the square. So my magic number is negative 6 over 2 squared. Negative 3 squared is 9. So we're going to get rid of the 10. X squared minus 6x equals negative 10. And then we're going to add our 9 to both sides, because this is x minus 3 squared. And that equals negative 1. And when we find the square root, we realize that the square root of a negative number is no real solution. Let's try the next one. And our page was getting a little crowded, so I've rewritten it over here. We want to start by getting rid of that a. So now we have x squared minus 10 thirds x equals negative 1. And we want to look at negative 10 thirds divided by 2 squared. So negative 10 sixths squared, 136. 136. Now, I would really like some common denominators here, and I know that I can reduce this. So this is, I'm going to divide the top and the bottom by 4. So this is really plus 25 over 9. So all of that goes away. And this is 25 over 9. And now I can make this into that very easily. I can turn this into a 30 over 9. And now I've got, and this is negative 9 over 9. So when I combine, I've got x squared minus 30 over 9x plus 25 over 9 equals 25 minus 9 is 16 over 9. Oh, I like that because that's a perfect square. And that's a perfect square. So we're going to pull this one first. This is x minus 5 over 3 squared equals 16 over 9. And when we find the square root of both of those, x minus 5 thirds equals plus or minus 4 thirds. So x equals, and I add 5 thirds to both sides, plus 4 thirds, which equals 9 thirds, which equals 3. Or x equals 5 thirds minus 4 thirds, which equals 1 third. So we have 2 answers. This is not hard. This is complicated. This is a lot to keep track of, and you can see how making one mistake can blow it. So please practice this. Please do not skip to the end and look at the answers and expect you to pass the test. Please take the time to get good at this. You don't have very many to do. Take that time, okay? Try check it out number 3. There are 2 problems there. Pause here and come back when you're done. So here's A. We divided everything by 3. So I've got negative 5 thirds x, negative 2 thirds, and 0. Then we found negative 5 thirds times 1/2 squared. That's negative 20, or that's positive 25 over 36 added to both. We changed 2 thirds times 12 times 12. This is 24 plus 25 is 49 36ths. And this is 5 sixths squared. So when we find the square root of this side and the square root of this side, we end up with x equals 5 sixths plus 7 sixths, and x equals 5 sixths minus 7 sixths. So I end up with 2 and negative 1/3. With B, I divide everything by 4. I find my negative 1 divided by 2 squared. I subtract 9/4 from both sides. I add 1/4 to both sides, and both of them squared. I end up with the square root of this equals the square root of negative 2. We see that there's no solution because there's no such thing. There is no real solution. There is an imaginary solution, but no real solution to the square root of a negative number.